That's Stray's tutoring? Hey guys, welcome to today's video where we'll be talking about the T4 Bacteriophage. And bear with me guys, I am a little bit under the weather, but I still want to go ahead and put out this video for you guys, just so you guys have a better understanding of what the bacteriophage is, the T4 bacteriophage, the anatomy, the function, and then other cool things that are worth mentioning. Because if you look at this thing, guys, it looks like an alien. It looks like some spaceship that's out of this planet, basically. And as a matter of fact, it is something that is normal and found in our bodies. So let's jump into the T4 bacteriophage. So what exactly is the T4 bacteriophage? Like, what is this thing? This thing looks crazy, right? Well, it's a type of virus that infects E. coli or Escherichia coli bacteria. Unlike viruses that affect humans or animals, the T4 phages are harmless to people and only target specific bacterial cells, right? So in this instance, for the T4 bacteriophage, it targets E. coli. It was discovered in the 1940s and widely used in research. So under the microscope, it also has this very unusual appearance, as you see here to the right, where it's often been compared to a tiny spacecraft, making them one of the most recognizable viruses in science. So recognizable, you guys may have seen them in Jimmy Neutron. There's an episode where Carl got sick. There is a little bit of misconception there, where they show the T4 bacteriophage, where it does infect E. coli, but not necessarily any type of human cells that would lead to a sickness. Like right now, I'm sick. You guys can hear it in my voice. I'm under the weather. A T4 bacteriophage did not infect some of my cells to make me sick. That is not the case. So although that show is very entertaining, I have to give them a D minus as far as accuracy when it comes to that. So beyond its role as a bacterial predator, the T4 phage is important in both science and medicine, of course. There's always some type of application here, right? So it's been used as a model organism for studying genetics, molecular biology, and even viral evolution. So because of its ability to specifically target bacteria, we're trying to explore other alternatives in antibiotics and phage therapy. So the T4 phage also replicates extremely quickly. So of course this makes it a very good model organism. In a lot of your classes, you guys learn about model organisms that are great for research. They use mice, they use E. coli or Drosophila melanogaster, right? Or fruit flies, whatever the case may be. So the T4 phages have kind of become this model organism as well, right? So now if we go into the anatomy of the T4 phage, right? It's composed of four main parts, right? The head, the tail sheath, the base plate, and then the tail fibers. So each is highly specialized for the infection. So the head or caspid is shaped like what we call an icosahedron and contains the phage's DNA. Attached to the head is a long tail sheath that can contract. This can contract and it's kind of like a spring, right? So at the bottom of the tail is a base plate, which acts as a landing pad when the phage is attached to the bacterium. And then from the base plate, it extends several tail fibers that help the phage recognize and tightly grip the surface of E. coli. So every part of the design works together to deliver genetic material to its host. And what we'll see in the next slide is exactly how this works. You'll see how the T4 bacteriophage lands on the cell and then injects its DNA. Now, if we go into the function of the T4 bacteriophage, there are two cycles. We have the lytic cycle and the lysogenic cycle. So in the lytic cycle, this is a fast and destructive method of viral reproduction. After the phage attracts to an E. coli cell, what it'll do is it'll inject its DNA into the host, and the viral DNA immediately takes over the cell's machinery, forcing it to stop its normal function and instead build phage parts, right? And then within about 30 minutes, hundreds of new T4 phages are assembled inside the bacterium. And then when the cell is full, it bursts open like a big boom. It bursts open in a process called lysis, releasing the new viruses to infect more bacteria. So the lytic cycle is, I think of it as these T4 bacteriophages are lit. They're ready to party. They're ready to mess up everything, destroy everything. So it's something that's fast and quick. It latches on. It reproduces new phage DNA, and then it releases all of them out to go and attack other bacteria. In contrast, some other bacteriophages can follow the lysogenic cycle, where the viral DNA quietly, this is kind of like a silent kill here, lysogenic. It will quietly integrate into the host genome and remains dormant for some time. So instead of an immediate destruction, being lit, destroying stuff, right? The phage DNA is copied along with the bacterium's DNA each time the cell divides. Eventually, under stressors, specific triggers, the viral DNA can switch up to the lytic cycle, leading to active replication and cell destruction. So T4 phages are strictly lytic, meaning they're always destroy the host cell rather than lying dormant, right? So this is a very interesting way for T4 bacteriophage to take over a cell and destroy it. So now we ask the most important question: why do they exist? Well, T4 bacteriophages are part of the natural balance between bacteria and viruses. So they've evolved over millions of years to survive by using bacteria as their host. So ensuring their own reproduction and continuation, right? So in the grand scheme, or in the bigger picture, phages like T4, they play this essential role in ecosystems by controlling bacterial populations and recycling nutrients when bacteria are destroyed. So all of this is going on even in your gut. You have E. coli. There is always some type of balance, some T4 bacteriophage infecting and putting their DNA to E. coli and destroying it. And without these guys, bacterial growth could become unchecked, and it would disrupt the natural the microbiome that you have. So in this way, T4 phages are not only fascinating, alien-like machines, but they're also important regulators of life at the microscopic level. So I hope you guys enjoyed this video. I'm happy you guys bared with me. I had to put this one out. Just a very interesting topic. I thought about it in my head. I saw Jimmy Neutron episode. I said, hey, wait, let me talk about the T4 bacteriophage because it's very interesting, and I think a lot of people don't know exactly what it does or its true function. So if you guys enjoyed the video, leave a like, comment, subscribe, do whatever you guys want to do. And I'll see you guys in the next one. Peace.